Okay, in this episode, we're going to deal with graphing cosecant. So we're now going to deal with cosecant of a vertical shift, something that's going to have a amplitude change. And because I have the function inside here actually being multiplication and an addition or subtraction, I'm now going to be dealing with not only a phase shift, but a period change. So let's go through and talk about how we do this. Well, it's based off the same idea as when we just graphed the regular cosecant function. It is going to be looked at as if I'm really just graphing y equals, instead of having cosecant, it's going to be sine of that function. So what I'm going to do is set this up as if I were graphing y equals negative 2 sine of 3x plus pi over 2. So I go about this the same way. The first thing I need to figure out here is what's my new period going to be, and the period is going to be 2 pi divided by 3. So done that part. And then I need to figure out what's my phase shift going to be. So what's my new start and end point going to be in this case. So I come up here and I solve the compound inequality of 0 is less than or equal to 3x plus pi over 2, which is less than or equal to 2 pi. Because the sine function, okay, has a period of originally being 2 pi, so does the cosecant, because it is just the inverse of it. So the 0 to 2 pi just deals with how long it takes to graph one cycle of the function, so this doesn't affect it. So all we're going to do is go through and solve for x to figure out what is our new domain of our function. So here we go. Domain, and when I talk about domain over one period. So I'm drawing this up here, and I have that less than or equal to 2 pi, so I'm just going to solve for it. So here we go. So I minus 2 pi minus pi over 2, minus pi over 2 minus pi over 2. So I get negative pi over 2 is less than or equal to 3x, which is less than or equal to 2 pi minus pi over 2 is 3 pi over 2, or 3 pi over 2. Divide by 3, so I'm going to be multiplying by the reciprocal, which is just 1/3, multiplying by 1/3, and what I get is a new period from negative pi over 6, which is less than or equal to x, which is less than or equal to 3 over 6, which is pi over 2. Okay, so I just reduced along the way of doing this problem. So what I now have is a new period from negative pi over 6 to pi over 2. So the next thing I need to figure out is, okay, is that correct? Well, if I take pi over 2, which is 3 pi over 6, and I subtract a negative pi over 6, I get 4 pi over 6, which is 2 pi over 3, which gives me the period of my one function, which matches up here. The next thing I need to check is, what does each interval step going to be represented by, and how much is it going to be? And the way you do that, again, take your period divided by 4. So 2 pi over 3 divided by 4 is 2 pi over 12, which reduces the pi over 6. So what I'm left with is, starting from negative pi over 6, each next interval of a critical value is going to be pi divided by 6 away. So if I start here at negative pi over 6, my next critical value is going to be at 0. And then at 0, after 0, my next critical value is going to be plus pi over 6 away from that. And then I do plus another pi over 6. Well, pi over 6 plus pi over 6 is 2 pi over 6, which is pi over 3. So my next critical value for this function is going to be at pi over 3. And then the final critical value for this one is going to be 3 pi over 6, which is pi over 2. Which for me, all I want to do is for one period of this graph. I'm not worried about going farther than that, so I'm just going to do one period. So now that I have one period on here plotted, I now need to deal with looking at everything else. I now have my graph labeled. I don't need to worry about that stuff anymore. So what I do need to worry about now is the 5 and the negative 2. So the 5 tells me my vertical shift. So I need to go up 1, 2, 3, 4, 5. So now my new axis is at 5. Okay, so there's my new axis. And then from there, okay, so I'm going to have to erase this function. I didn't make my graph big enough, I'm sorry. I'm just going to write it right here below it. So I'm graphing y equals 5 minus 2 cosecant 3x plus pi over 2. So I'm just going to erase this so I can bring it up here. So make my graph a little bit bigger. Okay, so there's my graph. Add some extra values in here. Okay, so I'm now going to deal with the vertical shift, and I'm going to start to look at my function. So There's my new axis, so now I'm starting again, I'm looking good. So now all I need to deal with my amplitude, and I need to find out is my function positive or negative. Well, in this case, the coefficient of the function is negative, so therefore for cosecant, again, I'm dealing with sine, okay? So I'm looking at with sine, I'm going to be starting off with this with sine, and it's going to be starting off at 0, because the sine always starts at its zeroing value. So at negative pi over 6, we're at 0. And then from there, the sine function normally would go to a maximum if we're positive, but it's going to go to a minimum because it's negative. So at 0, I go down 2, because my minimum is now 2 away, so I go down 2. Pi over 6 comes back to 0. Pi over 3 is now at a maximum. And then pi over 2 now completes the cycle of taking me back to at 0. So again, I'm graphing cosecant, but I'm going through sine. So I'm going to dash the sine function. So the sine function gets dashed. So there's the sine function dashed. And now from there, it's the same idea where I draw my values through the vertical asymptote. So anytime there's a 0, I go through a vertical asymptote. So 0 on the new axis that I've created. So there we go. There we go. And the next one I have to draw is right here. So there we go. And the last bit I have to now do is just invert my actual graph. So I take it through and I invert it. So there we go. And then I invert it. And again, I'm going to erase my dashed line so that you can see this a little bit better. But just want you to note that you don't have to actually erase it. I'm just going to do it so you can see it more clearly because I do have a lot of my graph. But you don't have to erase it because remember that a dashed line is imaginary and it's not really on there. We're just using it as a guide. So I hope that helps, but that's how you graph secant or cosecant with a vertical shift, a period change, and a amplitude alteration.